All right, welcome to Lecture 13, Part C. So in this part, we're going to learn how to determine an empirical formula, right? So last part, you figured out, you learned what an empirical formula is. And in this part, we're going to figure out how you can do some math to actually come up with it. So let's go ahead and get to it. Okay, so how do you find the empirical formula of a compound? So mainly there's going to be some calculations that go along with that. So let's do a little example. So let's say you found some compound out there in the world, and this compound was made up of magnesium and nitrogen, and you wanted to figure out like what's the actual formula of this compound. So another way of saying that is like, what are the subscripts? Is it Mg2n? Is it Mgn2? You know, I guess any combination is possible. Is it Mgn? You know, what are the subscripts? So to do that, what you would basically do is you would take this compound and you would break it apart. And you would put all the magnesium in one spot, and you'd put all the nitrogen in the other spot. Now, there's lots of ways of doing this. I'm not going to get into all the ways you can do this, but that's the basic idea. So we're going to separate the two elements away from each other. We'll stick all the magnesium in one spot, and we'll stick all the nitrogen in another spot. Now, it turns out if you do that, what you would find is that 72.2% of the magnesium would end up over in the magnesium pile. So 72.2% would end up in the magnesium pile. Like that would be the percentage of the weight there. And of the original weight, 27.8% of it would turn out to be in the nitrogen pile. All right, so we've separated the two, and we see already that most of the weight is in the magnesium pile. 72.2% of the weight is in the magnesium pile. 27.8% is in the nitrogen pile. So what are we going to do next? Well, basically, we're going to take those percentages and we're going to do some calculations and turn them into a formula. We're going to go from those percentages to knowing the subscript. Now, the calculations, there's a few steps to them. They can be a little confusing. I think the best thing I can tell you is they're pretty much calculations we've done before, all right? So you do need to do these calculations in a certain order. And in order to remember the order, I wrote you a little poem. Do you want to hear my poem? Of course you do. I tell you bad chemistry jokes. I write you bad chemistry poems. All right, so there's going to be 4 steps to do this calculation. Step number 1. Percent to mass. What does that mean? How do you do it? Oh, I'm about to tell you. Step number 2, mass to moles. Mass to moles. Oh, what does that mean? How am I going to tell you that? Oh, we'll go over that one in a minute too. That's actually something you've already done. All right, step number 3, divide by small. And then the last step, multiply till whole. Multiply till whole. All right. So, percent to mass. Mass to moles. Divide by small. Multiply till whole. When you do those 4 steps, you're going to get a formula. All right? How? Oh, let's do it. All right, let's go over it. All right. So step number 1, percent to mass. What does that mean? Well, what I mean by that is basically we're just going to switch the unit. And the way we're going to do that is we're going to assume 100 grams. It's the easiest to assume 100 grams. So if I was to assume that this original pile of magnesium nitride was 100 grams of it, that was the weight of it. What I would find when I assume that the entire pile weighed 100 grams, I would find after I separated the two elements, the weight of the magnesium pile, yeah, it's 72.2%, but I could also say it's 72.2 grams. So because the total is 100 grams, 72%, 72 grams of it would be the magnesium. Now the other pile, would weigh, if we pretend again there's 100 grams total, 27.8 grams. So there'd be 72.2 grams of magnesium and 27.8 grams of nitrogen. All right, so why are we doing that? We're basically just taking the percents and making them into a gram sign. And the reason we're doing that is so that we can do the next step, really. So, if, what am I doing, really? I'm just taking the percent, scratching it out, making it a G. Ta-da! All right. So, next thing we do, mass to moles. Mass to moles. Oh, another way of saying that, we're going to do grams to moles. That's another way of saying what we're doing there. Mass to moles. We're going from grams to moles. Now, how do we go from grams to moles? We did this back in a previous lecture. Grams to moles? Oh, wait a minute. That's where you use the periodic table, grams to moles. So you look at the periodic table, and we're going to have to do this calculation for both elements, for the magnesium and the nitrogen. We're going to take the weight of them, and we'll do them one by one here. And I don't know, maybe I'll switch to another color. It's kind of all running together. The 72.2 grams of magnesium, we're going to convert that to moles of magnesium. While we're at it, I'm going to do the same thing for the nitrogen. I'm going to take the 27.8 grams of nitrogen. I'm going to convert it to moles of nitrogen. So we're going to go from grams to moles. Periodic table. Oh, how did that work again? Oh, this is where we use the number under the symbol. So remember the number underneath the symbol. So for magnesium right there, it says 24.31. All right. Oh, and remember, what was that? That was a conversion factor. 24.31. There was a unit. 24.31 grams equals a mole. So that's for magnesium. 24.31 grams makes a mole. I'm using that number on the periodic table. Whatever number you see, that's the number of grams. And then the other side will always be equals a mole. So let's do the same thing for nitrogen. For under nitrogen, I see 14.01. So what is that telling me? 14.01 grams equals a mole. All right. So we've got our two conversion factors. One helps me go from grams to moles for magnesium. The other one helps me go from grams to moles for nitrogen. So we're going to do that for both elements. So we're going to convert grams of magnesium to moles of magnesium. And to do that, we got to use that 24 number, 24.31. So I'm going to let you think about this. You're going to use this conversion factor, grams to moles. Do you need to multiply by 24 or do you need to divide by 24? Are you going to multiply by 24 or divide by 24? Oh, I hope you decided you need to divide. So, how come? Because grams is what I'm starting with, so you got to put grams on the bottom. That makes the 24.3 go on the bottom. That makes the 1 mole go on top. That looks good because, yeah, again, grams will cancel and we get to moles. So if you work this out in your calculator, you basically got to divide. And when you divide, oh, let me check my notes here. You're going to get 2.97 moles. All right, so we had 2.97 moles of magnesium. All right. Maybe I'll draw a little line here. This is a separate step. Okay, so let's do the nitrogen. Same idea, grams to moles. We got to do that for both elements. 27.8 grams. We're going to go to moles, grams to moles. Now, just like before, if you start off with grams and you want to get rid of grams, that means you got to put grams on the bottom. And the number that goes with grams for nitrogen, oh, it's right here, 14.01. You should be dividing again by the weight off the periodic table for nitrogen. Oh yeah, that looks right, doesn't it? Because grams cancels. And then, oh yeah, 1 mole is going to be on top. All right, so when you divide it out, you get 1.98 grams of nitrogen. That's the weight of the nitrogen, 1.98. All right, step 2 is done. Grams to moles. Grams to moles, we do it for both elements. Grams to moles, you use your periodic table. To be exact, you divide by the number off the periodic table. All right, so now we're ready to do the next step. Percent to mass, mass to moles, divide by small. So what do I mean by that? What I mean by that is you got yourself two answers. You got the answer for magnesium. You got the answer for nitrogen. You take the big guy. There's going to be one answer that's bigger than the other one. You take the big one and you divide by the small one. All right. So what's the bigger number? Well, I think it's the magnesium, right? 2.97 is bigger than 1.98. So the way I'm going to do it is I'll take the magnesium number, take the big guy, and divide by the small guy, which is 1.98. Now, actually, you should do that for both of them. I'm going to divide both numbers by the lowest one. So I'll divide 1.98 divided by 1.98. So this is my nitrogen calculation here. All right. So let's go ahead and do it. And let's see what we get. So actually, maybe just to make sure you're following along here and it's making sense, let's go ahead and divide it. When you divide 1.97 divided by 1.98, what do you get when you divide 1.97 by 1.98? You get, you should be getting 1.5. And then for nitrogen, wait a minute, that one I can even do in my head. 1.98 divided by 1.98, I get 1. All right. So at this point, we basically have our subscripts, right? These are your subscripts. When we did all this work for magnesium, the answer for magnesium turned out to be 1.5. The answer that we got for nitrogen, I'm going to write a little line here. So again, yeah, the other one's the nitrogen answer. 1.98 divided by 1.8, we got 1. Oops, let me switch my colors back. Pardon me. All right, so you get N1. All right, so those are our subscripts. Mg 1.5 times N1. That is the formula. But doesn't it look a little weird to you? Because usually you don't have halves and stuff in formulas, right? So this is where the last step comes in. Percent to mass, did it. Grams to moles, did it. Divide by small. Take your two answers, find the lowest one, divide by the lowest one. Now, the last step is multiply till whole. So what does that mean? Multiply till whole. It means we're going to have to do something to get both of those subscripts to be whole numbers. So you're going to multiply both of them by something, 1 or 2 or 3 or 4 or whatever, to get them both to be whole numbers. Now, the way that it's going to actually work in this time, if I want to turn both of those subscripts into whole numbers, I can multiply both of them by 2. All right, and let me say that again because sometimes people forget. You got to multiply both of them by 2. So when you do that, your final answer, I think I can squeeze it in here. Maybe I'll put it in another color. You're going to get Mg, and 1.5 times 2 is 3. And then N, the nitrogen, 1 times 2 is 2. So that is your formula. All right. So yeah, there's a lot of steps, but if you break it down and kind of think step by step, I hope it won't be too bad. All right. We are going to do another little example here in a minute of another one. All right. So we'll try one more in a sec. Now, before I do that, I can tell you where people often get mixed up is this last step where it says multiply till whole. So let's talk about that just a little bit more, and then we'll do another example. Okay. So the multiplying by whole thing. Let's go over that just a bit more. Okay, so let's go off into Fantasyland just for a minute. Let's look at some other potential ways you might have to multiply to end up with whole numbers, okay? So in the example we just worked on, right, we got this, didn't we? We got mg, that should be a g there, 1.5, mg, 1.5, n2. And I told you, hey, you know what you got to do? You got to multiply by 2. And then when we did it, we figured out we got mg3 n2. So how did I know that to do that, and why did I end up multiplying by 2? Well, one way to know that is to think about really the problem is the 1.5, really the half part, right? We're trying to get rid of that 0.5. So 0.5 is the same thing as a half. So if you want to turn a half into like a whole number, the way you get rid of a half is you multiply by 2. You see how the half has, it's like 1 over 2? So if you multiply by 2, you'll end up with whole numbers, all right? Now let's look at some other potential ones, okay? Let's say you ended up with this. This could also happen, maybe in another problem, all right? mg 1.333 in 1. If you got that, and I told you, hey, don't tell me that is the answer because there's not whole numbers there, figure out something you can multiply by to end up with whole numbers. Multiplying by 2 wouldn't do it. What do you want to multiply by? Well, one way to think about it is my problem is the 0.3333333. 0.33333. That is really a third. So I got to get rid of the 0.33333. So how do you get rid of the 0.3333? If it's a third, you would multiply by 3, and that'll make the third go away. So if we multiply by a 3, we'll end up with whole numbers. Now, if you're not like sure this is working out and you're like, do I trust this guy? Is he doing it right? You could always try this on your calculator, but I'm just going to tell you what's going to happen. 1.333 times 3, you get 4. You would get a 4. And then again, don't forget, you got to multiply both of them. So 3 times 1, you would multiply 3 times 1 as well, just like you did here. 3 times 1, oh yeah, the nitrogen would be a subscript of 3. Actually, and I wrote the wrong thing here, didn't I? I misspoke. This should be a 4. I meant to say 4 and write a 4. Sorry about that. I was thinking ahead. All right, so what are some other possibilities? All right, let's do some more. So there's a few you might run across on homework or whatever in class. mg 1.25 in 1. Don't give me that. Make it whole numbers. So how are you going to do that? Well, 0.25, that is the same thing as a quarter. 0.25 is a quarter. So to make a quarter go away, it's the same idea. You're going to multiply both of them times 4. So when you do that, 4 times 1.25, well, you try it on your calculator if you don't believe me. You get a 5, mg5. And then you got to do the same thing, 4 times 1. You multiply them both times 4, you get n4. All right, there's only one other common one you're going to run across, and you might run into this. mg 1.666667 in 1. All right, you can't give me that as a formula. You got to get rid of the 0.66666. So the way you're going to do that again, we got to find something to multiply by to make that 0.6666 go away. So 0.666, as far as being a fraction, that's really like 2/3. All right, that's really like 2/3. 66%, you could think of it that way, that's like 2/3. So the way you would get it to go away, actually you would end up multiplying it by 3 again. All right. So if you multiply by 3, what you would get this time, if you multiply 3 times 1.666, you would get 5, actually. You can try it on your calculator if it doesn't seem right. It is, though. And then you would do 3 times 1 for the nitrogen. So that would give you N3. All right? So these are your common possibilities. Maybe they'll run across some weird ones, but these are the most common ones. You got a third, make a third go away. All right, multiply by 2. Half, I should say. You have a third, make it go away. Multiply by 3. You've got a quarter, make it go away. Multiply by 4. Or maybe you have 2/3, make 2/3 go away. You multiply by 3, actually, again. All right, so with that, let's try one more of these. Let's try one more. Let's see how it goes. Let's try one more. All right, so I'm going to flip over to the next page, and we'll do another one. Okay, let's do one more where we're trying to find the empirical formula. All right, so And this one it says aspirin is found to contain 60% carbon and 4.48% hydrogen, 35.53% oxygen. What is the empirical formula? Take those numbers, make them a formula. Give me the subscripts. All right, step 1, percent to mass. What does that mean again? Just take the percent signs and make them gram signs. That's all you do. All right, so we're going to take the percent signs and we're going to make them gram signs. So we'll do 60.00 grams of carbon. And then I'm going to switch colors so it's a little easier to follow, I hope. 4.48 grams of hydrogen. And then we'll do the same thing for the oxygen. 35.553 grams of oxygen. So for every single one, I just took the percent signs, making them gram signs. Step 2, percent to mass, mass to moles. So what does that mean? It means take every one of those grams and convert them to moles. How do you do that? Your periodic tables. So we'll look up for carbon. It says 12.01. For hydrogen, it'll say, let's see here, it'll say, what does that say? 1.08 for hydrogen. And then for oxygen, it'll say 16. Now, every single number we just looked up is really a conversion factor. There is a way to make that a conversion factor. Whatever you see, that is how many grams equals 1 mole. So after you look up the number, whatever you see, write grams next to it. Always grams, always equals 1 mole. I promise, I promise, I promise. That's the way it always works. All right. So now we got our conversion factor. So we got our grams, and now we're going to go to moles. So we have to use those conversion factors. So grams to moles for carbon. Grams to moles for hydrogen. Grams to moles for oxygen. All right. Now, you're going to do it the same way every single time, right? You're going from grams to moles for every single element. So just like I showed you in the first video, or the first example on this video, I guess, the way you do that, if you got grams, you got to put grams on the bottom. That means that you'll be dividing by the number off the periodic table. As soon as you write G on the bottom, the 12 goes on the bottom. And then it should look like this. Oh, does that look right? I think so, because grams is going to cancel. For hydrogen, same thing. We got to get rid of grams. That means you got to put grams on the bottom. For oxygen, yeah, we got to get rid of grams. What does that mean? It means you got to put grams on the bottom and the 16. So yeah, the number is different. It depends on the element, but what you're doing is really the same thing. Grams to moles, take that and use the periodic table to get from grams to moles. Now, when you work it out, this is what you're going to get. The first one, it turns out to be exactly, well, pretty much exactly 5 for carbon. And when you work it out for hydrogen, you get 4. Oh, wrong color. Trying to be good. I'm trying to write a lot on this little screen. You get 4.44. And then for the oxygen, when you divide, you get, oh, what I get? 2.22. All right. So that's the second step. Percent to mass, mass to moles. Now, what's the third step? The third step, and I'm going to put it over here because I'm going to have such a little room, is divide by small. Now, you got 3 answers this time. You divide by the lowest of the 3. So I promise this is not a trick question. What number should you be dividing by? You should be dividing by 2.2. So you're going to take every single one of those answers, the answer for carbon, divide by the lowest of the 3, the 2.2. You're going to do the same thing for hydrogen. Take its answer, divide by the lowest of the three. 2.22. And then the same thing for oxygen. Take its answer and divide by the lowest one we got. So, hey, the one on the end, man, that's easy, right? 2.22 divided by 2.22, you get 1. All right, what about for hydrogen? For hydrogen, when you divide it out, you get 2. If you divide 4.44 divided by 2.22, you get 2. And then when you do it for carbon, you get 2.25. All right. So that's basically our formula, except there's one more step. And shoot, I'm going to have to squeeze it in up higher, I think, huh? Which is the last step is multiply till whole. So let's see what we got right now. What I have right now is carbon, we ended up with 2.25. And then we got for hydrogen, we got 2. And then for oxygen, we got 1. All right, so I'm going to ask you a couple of questions about this. Those are your current subscripts. They're not that great, right? Because we have like a decimal in there, not supposed to. 2.25 is the problem, the carbon's subscript. So question 1, if those are your subscripts, what would you multiply by to make them whole numbers? What do you need to multiply by? Okay, I hope you said 4, right? Yeah, you're going to multiply by 4. And then when you multiply everything by 4, what are you going to get? What will be the subscripts when you're done multiplying? All right, hopefully you got that one right. If not, you know, you can always talk to me, or we'll go over this in Zoom or something. I'll be glad to give you some more examples or help you out if you're confused on this. All right, so with that, let's move on to something different. The end of this lecture.